in looking at the video, one of the first questions, of course, is whether or not the airplane was properly configured. The flaps appear to be up or at a minimal setting that wouldn't be typical of a normal takeoff.
Right.
And at 600 feet, the landing gear should have been up. It's very hot. It was very hot there. It was probably 100 degrees or thereabouts Fahrenheit. You have to account for that high temperature because that affects, being that this is a Boeing 787. This is the first fatal accident the aircraft has had.
Right.
Regardless of what everybody else has said over the years about the issues at Boeing and everything else, we don't know if this is an actual airplane problem or something else. Unless the aircraft gets into either hitting a flock of birds, like similar to what happened with the Miracle on the Hudson.
Right.
Sully Sullenberg, where right after takeoff, they flew through a flock of geese and had an issue.
Right.
That's a rare event. Or the airplane is taking off into weather conditions that may have caused wind shear or some other wind or weather event that would affect the aircraft's ability to fly. It's kind of like being at a crime scene.
Right.
Where even the smallest of evidence, and as they say, devil is in the details.
Right.
It's the little things. A bunch of stuff on the internet, which I know is totally wrong. But to the untrained or person who is not, conversant with aviation, they may see that as fact when in fact it is fiction.
My first question to you, Greg, is that, I'm not sure if you've seen the video of the crash. There are just, a couple of seconds of that video that's out there in the public domain. But what we do know is that, according to the flight tracking data, the signal from the aircraft was lost at an altitude of about 625 feet. So that's sort of within, if not seconds, then within a minute after takeoff. And that it descended with a vertical speed of about 475 feet per minute and then crashed thereafter. What is your initial impression, especially given that the crash occurred shortly after takeoff, like within 1,000 feet of altitude?
Well, there are a lot of different aspects to the operation of a Boeing 787.
All right.
In looking at the video, one of the first questions, of course, is whether or not the airplane was properly configured. That is, there is a certain configuration that the wings must be in with the flaps deployed because the airplane needs to have extra lift when it's heavy, low, and slow. That is typically during the takeoff.
Right.
So you have the trailing edge wing flaps deployed, changes the camber of the wing, produces more lift, and since the airplane is at its heaviest during takeoff, you need that lift.
Right.
The thing that's curious about the video is that the flaps appear to be up or at a minimal setting that wouldn't be typical of a normal takeoff.
Right.
And at 600 feet, the landing gear should have been up.
Right. Right.
Okay, so now the question is, well, why wasn't the landing gear up?
Right.
Was it a hydraulic problem or an electrical problem? Because that landing gear is hydraulically held in place.
Right.
And it's also retracted.
Right.
The flaps are electric. So the question is, why are they in an improper position that low? When you watch the video, the pitch attitude, that is the nose up attitude of the airplane,
right,
appears to be in a normal climb attitude.
Right.
Yet the airplane is settling into the ground,
right,
which again could have been because there was inadequate thrust from the engines, from both engines. And there are a number of events. there was an accident here in the United States involving a Northwest airplane where the pilots did not have sufficient sufficient flap setting for the airplane to take off. And they tried to make the airplane fly. The airplane then settled into the ground, crashed on a highway, and killed the majority of the people. So aircraft performance is going to be a critical aspect of the investigation. The other thing the investigators are going to need to look at is, were the engines producing proper thrust? Now, this is a very computerized, highly technical airplane. So the crew has to account for a proper weight of the aircraft. It's very hot. It was very hot there. It was probably 100 degrees or thereabouts Fahrenheit. You have to account for that high temperature because that affects engine performance and aircraft performance. And if you didn't have the proper thrust setting, then now all of a sudden you don't have sufficient thrust to keep the airplane airborne once you get it off the ground. So the investigators are going to be looking at crew procedures and operation of the airplane.
Right.
How they set the airplane up for the takeoff, because they would have probably been very heavy, 242 people, and not necessarily a full load of fuel, but quite a bit of fuel. Okay? Aircraft performance, and then, of course, they're going to look at the mechanical aspects of the airplane. Were the engines producing thrust? If they weren't producing thrust simultaneously, there's only a couple things that can have an adverse effect. One is fuel, because fuel is common to both engines.
Right.
Was there contaminated fuel, or was there some sort of fuel delivery problem that caused both engines to reduce their thrust inadvertently? The other thing is, that there's again so many different aspects in this investigation based on just early information from the video.
Right.
But there are a lot of things that won't be known until we get better data. Like data recorder and the cockpit voice recorder.
Greg, just a quick follow-up. You spoke of appropriate flap setting. Just for an average person, when does that take place? Is that before the takeoff? Is it during takeoff? Because that I'm not sure if our readers would understand that.
Yes. The trailing edge flaps, the wing flaps, are typically set by the flight crew prior to initiating the takeoff. Okay. And the wing flaps change the shape of the wing so that at a low speed, the wing produces more lift when the flaps are deployed. As they climb out, as they climb and they increase altitude, then you reduce the flap setting so that when you're in cruise flight, the wing is at its optimal shape for high-speed flight.
Right. And the fact that you said that the nose of the aircraft was still at an incline, even as it was descending, you're saying that could indicate that the engines were maybe not producing enough thrust?
Based on that pitch attitude and the fact that the flaps do not appear to be in the down position, that could indicate that the pilots were holding that climb attitude, but they had insufficient thrust for the airplane to actually climb. The other thing is that because they were so low to the ground, they were trying to keep the airplane flying. So they were holding a pitch attitude and, basically gliding the airplane as far as they could if there was insufficient thrust, either because the engines rolled back or they had actually flamed out due to a fuel problem.
This was honestly, this is a bit speculative, but we did read about this a lot on social media where people said that, a crash like this indicates that both engines gave out very quickly. Is that something that you think makes sense to you?
Well, yeah, that's what we were just talking about, is that, again, if both engines were not producing sufficient thrust
Okay.
to keep the airplane airborne.
Right.
But that's a lot of speculation because, one, you can have, if the airplane isn't properly configured, if you didn't have the appropriate flap setting, then once the airplane gets airborne, the wing can't produce the amount of lift necessary to support the weight of the aircraft during that slow speed flight in the climb.
Right.
And the airplane, you get what we call in the industry, you get on the backside of the power curve.
Right.
You don't have sufficient thrust to support the weight of the airplane, and the airplane will mush or settle into the ground in the attitude that's shown in the video.
Okay.
So you could have perfectly operating engines. It was just that the wing wasn't properly shaped to support the weight of the airplane, creating enough lift.
Right. Greg, what does the altitude of 600 feet tell you about the phase of flight and the pilot's workload at that moment?
Typically, in that particular phase of flight, the airplane would have been on the takeoff roll. They would have rotated. The airplane would have started its initial climb.
Right.
Once you establish a positive rate of climb or rate of ascent, the call out is positive rate, gear up.
Okay.
So the pilot monitoring calls positive rate, gear up, and the flying pilot will make that command and it's executed. That's why it's curious that at 600 feet the gear should have been up.
Right.
And it wasn't.
Right.
So is that because you have an engine problem or engines problem? Is that because you have a hydraulic problem? Is that because the pilots became consumed with taking care of another problem and did not get the gear up? There's a number of different scenarios based on what the pilots would have been dealing with. The takeoff and climb under normal circumstances it's not a heavy workload, but it is a workload where both pilots are focused on monitoring instrumentation, with the engines and the performance of the aircraft. And if a problem developed that didn't allow them to pull the landing gear up, or there was a hydraulic system problem where the flaps retracted on their own, that creates performance problems, and now the pilot flying really has to expend a lot of mental processing to assess what's going on and then take the appropriate corrective actions.
So how much of a room do you think a pilot would typically have to recover from an emergency at such a low altitude, just within minutes of takeoff?
That's a hard question to answer because it's all dependent on the nature of the problem. Let's say, for example, during the takeoff and the initial climb, only one engine failed. The airplane is certified to fly on one engine.
Right.
So the pilots would continue doing what they were doing, and that is continuing the climb, monitoring the aircraft performance to get to a safe altitude. So you can have one engine failure and still be able to fly the airplane.
Right.
So again, if they had a total electrical failure, the airplane will still fly. And it just takes a different course of corrective action. So being at 600 feet is just an altitude.
Right.
Determining what the pilot should be doing to correct the situation is based on the situation.
So I think you would have read this, but the pilot had over 8,000 hours of flying experience. The captain was highly experienced.
Yes.
in that context, against that backdrop, does the crash surprise you in any way?
At this moment, there is no reason to be surprised because we don't know what the crew was dealing with.
Okay.
Was it an airplane problem that they couldn't correct at that low altitude? If you look at Jeju Airlines, the 737.
Yes.
That crew flew through a flock of birds.
Right.
Both engines rolled back. So now you have, the pilots trying to do what they think is best, based on their experience. And they got the airplane back to the airport.
Right.
It was for the fact that they didn't do all of the other necessary procedures to put the wheels down and stop the airplane, or at least try and slow the airplane down before it went off the end of the runway.
Right.
In this case, we don't know what those pilots were dealing with. And until we have a better understanding, it's hard to be critical or supportive of the crew actions because we don't know what they were dealing with.
Greg, going by the past data, for the benefit of our readers, how common are air crashes during the takeoff phase? I mean, would you consider them rare or relatively frequent? I mean, just to a sense of that.
For a major air carrier worldwide operating as an airline, takeoff accidents are rare. Okay. They do happen and have happened because I've investigated them over my career. Right. But they are rare events.
Okay.
And now, being that this is a Boeing 787, this is the first fatal accident the aircraft has had.
Right.
Regardless of what everybody else has said over the years about the issues at Boeing and everything else, we don't know if this is an actual airplane problem or something else.
Okay. When you say that it is relatively rare, could you again, for the benefit of a layperson, just explain why a takeoff crash is relatively rare? Say, compared to, say, a crash during the landing phase?
Yes. Typically during takeoff, the crew has had time to prep the airplane while they're sitting at the gate. They're configuring, they're making sure that their flight management computer has all of the relative information necessary for determining what the proper engine thrust needs to be for the takeoff.
Right.
As they're heading to the runway, they're configuring the airplane. They're putting the flaps at the appropriate setting for the conditions that they're taking off. And then on the takeoff roll, of course, both pilots, one is flying the airplane, the other one is monitoring what is going on as far as aircraft performance, with airspeed, with engine thrust, and everything else. Unless the aircraft gets into either hitting a flock of birds, like similar to what happened with the Miracle on the Hudson. Right. Sully Sullenberg, where right after takeoff, they flew through a flock of geese and had an issue. Right. That's a rare event. Or the airplane is taking off into weather conditions that may have caused wind shear or some other wind or weather event that would affect the aircraft's ability to fly. Those are rare events because pilots don't take off typically into bad weather. They're very cognizant of what's going on during the takeoff phase of flight, and that if we have more prevalence of landing accidents because the airplane pilots are going to their destination. The weather conditions may have more of an adverse effect on the landing performance than on takeoff performance. So unless there's something that has a very impactful event on the aircraft that either inhibits or prevents a pilot from being able to remedy or put the necessary corrective actions in place, these takeoff events such as this are very rare. We have had them where, like I said, Northwest 255 in Detroit years ago here in the United States, the pilots failed to put the flaps down into the proper configuration, so that when they tried to take off, the wing didn't produce sufficient lift. And similar to what the video shows in this accident, the airplane settled back into the ground on a highway, and unfortunately killed everybody except for one person, killed everybody else on board. So again, but that was years ago. So we haven't had those kinds of accidents with major commercial airliners.
When did the Detroit event happen? When you say years ago?
That happened August 16th of 1987.
Greg, say hypothetically, if you were leading this investigation, based on your past experience, what would your priorities be within the first few days of the investigation? Do you think are there patterns in similar crashes that investigators should be alert to? You have mentioned about the flap setting, but
yeah, the focus, if I was running this investigation, there are multiple aspects. One, a priority would be, of course, to recover the flight data recorder and the cockpit voice recorder.
Right.
Because that is going to give the investigative team the best information to determine the path for which this investigation is going to go down.
Right.
They have to determine if there is an aircraft issue or a pilot issue or a combination of both. So that information is critical. So that would be one priority. The other priority would be, of course, getting as much video evidence as possible, such as what's already out there on the internet, and to see if there's any other video from the airport security system. Will we be able to see the airplane at the gate? Will we be able to see if the airplane was properly configured as it was as it was taxiing to the runway and on the takeoff roll? That information could be captured in video by airport security video. That will help investigators, again, determine, okay, do we look at the airplane to see if there's a mechanical malfunction, or do we focus more on the flight crew and their procedures? And then, of course, looking again at the physical wreckage at the accident site to determine, if there is anything that is evident from the physical wreckage that would suggest or support a mechanical malfunction or failure of the aircraft.
What at the site of the accident can actually indicate a mechanical failure? What are those clues which would indicate that? Because again, the site of the wreckage, a lot of it just seems completely destroyed at this point.
Correct, but that is the forensic part of the investigative process.
Right.
So you are looking for components or things on the airplane that are not normal. So let's say they find the flaps, the wing flaps, trailing edge wing flaps, and they look at the mechanical device that moves those wing flaps. They will measure the jack screws to see, how much the flaps were deployed. You could have that one flap was deployed, to a 5-degree position, and on the other side of the airplane, the flap was deployed to a 15-degree position. That is an anomaly. So now the question is, why did that happen? You look at in the cockpit, based on what's in the cockpit. You can look at the throttle or thrust lever settings. You can see the position of the thrust levers, or you can see the position of the flap handle or the landing gear handle. And then you can compare that to data on the flight data recorder. So if the flight data recorder said or shows that the landing or the flaps were in the up position, or the landing gear was in the up position, yet physically we know the gear was still down, that's an anomaly. That's why the forensic part, the on-scene, the thorough and methodical approach
Right.
that investigators take in examining the parts and components of the airplane is so critical. Even in an accident like this, where the destruction of the airplane, looks beyond, well, you can't figure out anything. Yes, we can.
Okay.
It's kind of like being at a crime scene,
Right.
where even the smallest of evidence, and as they say, devil is in the details.
Right.
It's the little things. It is not the big things that provide a lot of the clues. I think right now, with all of the media coverage,
Right.
especially and a lot of the chatter that is on the internet,
Right.
by so-called experts, and all of the hypotheticals and the theories that are floating around out there, that can lead people, especially passengers who are going to get on an airplane, or are going to base their decision to get on an airplane based on what they've read on the internet. That has to be taken with a high level of caution, because you have a lot of people speculating a lot of things without having really any facts other than a video that is circulating out there.
Right.
I've read a bunch of stuff on the internet, which I know is totally wrong. But to the untrained or person who is not, conversant with aviation, they may see that as fact when in fact it is fiction.
Right. Right.
And so people need to just take a step back, allow the process to start, because as they get new, as the investigators, because there's a team coming from the AAIB in the UK, the NTSB is coming over as well.
Right.
So as information over the next 48 to 72 hours comes out, that may give us a better understanding of what was taking place, and whether this was airplane issue, pilot issue, or a combination of both.
How long do you think it kind of typically takes for an investigation to conclude and maybe, arrive at something conclusively?
In this particular instance, the investigative process is twofold. The first part of the investigation is to get as much information for the investigators, get as much information as possible to determine whether or not there is some sort of deficiency, inadequacy, or failure of the system. When we talk about the system, we talk about, policies, procedures, regulations. Was there an issue with the airline, as far as policies, procedures, training, things like that? We also need to know if there were any deficiencies or failures of the aircraft. That all of these things could have an adverse effect on flight safety. We need to know that now so that we can affect change now, because these accident investigations typically take 18 months to 24 months. We don't want to wait 2 years to try and fix a safety problem, because we still have airplanes flying. So we try to get as much as we can early on to see if we got to fix the problem, but the entire process will probably take between 18 and 24 months.
Right. And what's the reasonable, when you say try and get as much information early on, what would that reasonable amount of time be so that you are able to at least take some corrective measures?
I think if the cockpit voice recorder and the flight data recorder provide useful information, because these boxes, while they are built to be somewhat indestructible, they have failed in the past. I've had to deal with that in the past. But assuming that they're going to get good data, not only from the CVR and the FDR, there are other methods. That airplane is constantly pumping data to the ground. So we have other repositories of data. If we have good data, I would expect that if there is any kind of issue that has an adverse effect on flight safety, we would know about it within a week.